Hello, and welcome to the video version of the History of CAD podcast. My name is Rupinder Tara, and I'll be your host. On this podcast, we will explore the untold stories behind the tools that shape modern engineering and design. Each episode features conversations with the pioneers of computer-aided design, the innovators who built the software, those who worked alongside them, or those who observed or reviewed their work.
I have a sailboat.
Okay.
It's 11 meters, which I'm sure you can translate as 35 feet. It has a 5-foot draft. It's a cruiser.
Have you ever sailed down the waterway?
I think I got as far as the Elizabeth Islands. There's plenty of places to sail.
So, Mike, everyone calls you Mike.
It calls me Mike.
Did the
Well,
Americans do
most
that to you?
people.
Did the Americans do that when you moved here? You started calling you Mike?
It just seemed more friendly than Michael, you know.
Okay.
My sister calls me Michael.
Uh,
Her husband calls me Mike.
yeah. So you moved here in 69.
How did you know that?
Well, it's just 2 years after I moved here in 67. So that year stuck in me. I think it was in David Weisberg's CAD history as well. And you were educated in, when I start this, I'm going to give you the whole history of Mike Payne, as it were.
Okay.
So I'm going to have that recorded and I'll recite that as an introduction to you, but we can fill in the gaps here on this show. And so mainly you're a co-founder of 3 CAD companies, PTC, then SolidWorks, and then SpaceClaim.
Yes.
Okay, so that's the main accomplishments. I'm going to list Canesto too, since you're founder of Canesto.
Essentially, yes.
Back to your days in the UK, you got your start in studying semiconductor. Oh, no, it's not semiconductor, vacuum tubes, right?
I never did vacuum tubes. That was how I chose that particular university.
Okay.
Yeah. But then later, I had an emphasis in the physics of semiconductor and vacuum devices.
Oh, I see.
That was not just those valves, as they were called in the English vernacular.
You studied physics. You have that in common with Elon Musk. I think he got his degree in physics. He chose to study the first principles, and from that, he could understand engineering. That first principles is physics.
Isn't that true? Yeah. What can I say?
Is that where the resemblance stops?
Look, I went to college when there were very few colleges that had computers in undergraduate school.
You did, that's right. So what were engineers doing now? They had slide rules at that point, right?
Oh, yeah, we had slide rules, and they're a very complex piece of equipment. Very simple to use so long as you understood logarithms.
I think a lot of people say that it gave them a better understanding of math and gave them a better understanding of numbers than calculators do. By the way, I don't know if you have seen this, but could you see this?
What is it? It's flashing.
It's a circular
slide rule. I've got one somewhere. I just can't find it. It's another thing in this life, right?
I keep a few of them around, and I don't have the lid sliding one anymore, but I have the circular one. Okay, so were calculators yet a thing, or did engineers even have the Hewlett-Packard calculator yet?
I didn't know I'd have to use the computer, but I had a senior project about microwaves and seeing how concrete had matured, cured by its dryness and the reflection of microwaves. And so it was these complex equations that needed to be solved. And so the best way was to figure out how to program a computer to do it. And it had a time sharing system that was very different. You stood in line with your punch tape behind the other guy. And when you punched it wrong, it would fail and not compile or whatever. And the reams of paper would come out of a line printer. And you'd have to go back and stand in line again after you changed the holes in the paper. So you tried to get it right first time.
So you wouldn't have to make that tape again or punch cards.
I mean, at that time, only places like Manchester and MIT had computers.
You're bringing back memories. I still remember those punch cards, clicking like a deck of cards,
That's right. If you were smart, you put sequence numbers on in the right-hand 8 columns so that you could sort them back in order when you drop them.
Oh, what a good idea. See, this is why it never ended up being anything. Anything.
That's what it's for, the sequence numbers. You didn't number them sequentially, you numbered them in tens or something. But
Yeah.
that was another story.
Were you first introduced to computer graphics that eventually became CAD? Was that at Prime?
The graphics didn't come for a long time. That was when I was on the board of CAD Center and we were selling PDMS as Prime Computer, another defunct computer company like Digital. We sold PDMS, which came from a British research center called CAD Center. This produced on very crude graphics devices by what today's standard is, pictures of piping and valves, which was probably the first real aspect of 3D modeling that was useful.
So and you saw computer graphics at CAD Center. It's
Yes.
your first introduction.
Yeah, and we had some crazy devices. I mean, they were expensive and complicated. Tektronix was one of the suppliers. So that couldn't be the future. I
Yeah.
mean, it was the present, but it couldn't be the future.
Now, did you realize that at the moment, or is this in retrospect you see that this was quite not the way to do things? Like this would never take off if you thought this was just crap.
No, it wasn't crap because people were building nuclear power stations using this software and oil refineries and oil rigs and all the things that needed piping.
So piping is a practical use.
Graphics was not wonderful. That didn't mean you couldn't work with it. So we're going back to the early 80s when things were beginning to become commercialized.
Mm-hmm.
People in colleges playing with surface models and designing aeroplanes at Dassault Aviation.
Yes, serious.
So we're talking, what, 40, 50 years ago.
Yeah.
And so it all evolved over time, like everything, which is another lesson, of course, is that there are no revolutions. It's all evolution. You can't just say, tomorrow we're going to do this. So it evolved over trials and experimentation, and then you moved on. Things got more memory, more speed, better pictures, and that was a total evolution.
Yeah, you can blame the media for giving that name, revolution, I think.
Evolution is what has gone on from the first computers, which were, you could say, the first computer was the Enigma machine.
Who made that?
That was Alan Turing's thing in the Second World War. You could argue, but what they made was a computer, which they destroyed.
Okay.
And that was to decode the ciphers. Oh, yeah. And a lot of that stuff is on show in Bletchley Park.
I got the feeling from researchers at that time. I understand they were used for important things like bomb trajectories. You used them for curing of concrete.
Yes.
That's important, but still drawing all the effort that it took to make a little line from point A to point B. Somebody had to say, we're just making pretty pictures here.
That was the early machines like computer vision and Applicon, which I used and hated them. But it was better than making ICs with tape that you could forget to remove on the printed circuit board, where that got photographed. But adhesive tape, what a mylar that you photographed and made chips out of.
I remember. At what point do you think somebody said, hey, we should be showing our objects on the computer instead of a drafting board?
Well,
idea came
one of the things that Prime had was the rights to sell, and then it had to develop Medusa, which was a 2D drafting, which had some elements of 3D. Much better drafting system than AutoCAD, but then AutoCAD had the advantage later of being on the IBM PC and everybody could buy cheap equipment and do drafting. It only shows the volume guy wins in the end. Medusa was a much better system, and so were others, but the volume guy won. And today, Autodesk gets a huge amount of money every year from AutoCAD. Exactly how much, but it's north of $1 billion, I think.
Well, because it's a democratic thing. It's the numbers,
And all
owners
because they
rule.
put it on the
Yeah.
PC.
And the PC, even though Medusa was better, PTC was
Oh,
better,
yeah.
everything is better,
I'm
right?
not so sure about Cadam, but that's another story.
You were head of development at Prime. You were head of development for the computer-aided
Well, not
design, right?
computer vision. I was never at computer vision. That
No,
is
not computer vision.
misnomer due to the fact that Prime merged with computer vision
Okay.
at the time when they were both going downhill, but made them go downhill faster.
I call that two rocks tying themselves together, hoping they'll float.
That would be like putting Sears and Kmart together.
So what was sinking them? Why were they not popular, given that they were just too expensive? It's
Which is
competition?
computer vision. They were
Yeah.
expensive. They were 2D. They really didn't have any 3D. They had some simple wireframe, but wireframe is pretty useless for designing things. That evolved before solids. And then there were attempts at solids, but the solids were, I've shown the boss that I can make a solid model, but you couldn't change it. You had to start from scratch. And this was the fundamental difference with Pro Engineer, better known today as Creo. It started out as an idea. Sam started the idea. He showed me one morning after breakfast, look, we can make a bracket with a hole in it, dimension the hole and the location of the hole, change the size of the hole, change the location of the hole, and lo and behold, we have models that we could change.
That was Sam Geisberg, the founder of the PTC, Parametric Technology Corporation. And
Absolutely.
did he recruit you for
Yes, his brother had worked with me running the mechanical section where we had to improve Medusa. And I had left Prime, and I get this call from a guy with a very heavy Russian accent saying, my name is Sam, you don't know me, but I'm doing this thing in Billerica, Massachusetts. My brother said I should talk with you. So would you like to have breakfast? So I went and had breakfast with Sam.
Vladimir, right?
Vladimir was the brother.
Okay. Very Russian. Vladimir, you had a clue.
Yes, but Vladimir didn't have such a thick accent, Sam. Anyway, he shows me this, and I look at that. I said words to the effect of, this is what we should have been doing at Prime. Maybe we can do something with this. And he said, oh, would you join me? But I don't have any money. But we're trying to raise money. And there was another guy, Danny Dean, who was the group that started parametric technology, the three of us.
They're pretty much startups. I don't even know if they were maybe paying themselves at this point. Didn't it happen again when you joined SolidWorks?
It was really hard to raise money because there were venture guys, there were people who were experts, and we would run into the experts. The experts weren't expert at all. They just thought they were experts, and oh, that'll never work. Well, the fundamental difference between what everybody else was doing at that time was we didn't change the geometry. We made a recipe to make the geometry. I'm not telling any trade secrets. It made a recipe, and you replayed the recipe. And that was the list of features that you wanted, because the computers weren't fast enough to do what HP was trying to do at the time with direct modeling, because that takes a lot of computer effort. We were there in the era of mini computers.
Yeah. You mentioned HP, Mike. What was that HP's program? It eventually became Creo, didn't it?
It became Co-Create,
Right.
Co-Create. And they were doing that in Germany, in Berlin, I believe. And you didn't have the horsepower to do it. So we used mini computers, okay? That was the first embodiment. There were two. We had it on a VAX, which you've never heard of, and we had it on an IBM PC, but it couldn't stay on the IBM PC because it was 16 bits, which soon ran out of address space, memory space in general, and everything.
So I remember DEC because that was Ken Olson's company. Why didn't you go up to Prime? Didn't you run on
We
Prime?
had access to them
Oh, okay.
at Adage. But as we started to develop this, we decided that we were not going to play anymore with remote graphics. There were these emerging workstations like Sun and Silicon Graphics
Okay.
and the microvacs. We focused on those where the graphics was included with the CPU, which was a lot different than having a remote Tektronix display. The cost was better, so it became affordable. The key thing that PTC did at the very beginning was to go to those workstations exclusively. It was the next 10 years from the time we started till it wasn't the way. But there were 10 years that these workstations flourished, got faster, and that forced us into how we stored the data because it had to work on different architectures with different byte orders and bit orders. And the only way to really do that was to make it textual and let the operating system figure that out. So the data was stored in text form. Right. Because there had to be different computer formats. One of the problems we were determined to avoid was things that computer vision had to have upgrade things. You had to move your data to the next version with some conversion, which was ridiculous for the user. So we tried to make it that this version's data would work with the next version.
Yeah.
But with Pro Engineer, we had to do everything. We had to write double byte language stuff if we wanted to support Japanese characters. We had to come up with our own storage. We had to do our own graphics. There was no hoops or something until later after we did graphics. Then Carl Bass showed up and said, I got this lovely graphic software. I said, that's very nice. What do you want us to do with it? And he said, it's wonderful and you should buy it. And I said, well, maybe I should show you what we've got. And he says, where did you get that? I said, well, we do 3D modeling. We have to show it on the screen. But then we couldn't buy it from anybody, so we wrote it. Oh, and it was pretty good. So Carl went away with that. That was probably his first failure to get a sale.
Now, this is Carl Bass, but he was eventually CEO of Autodesk.
Ithaca Software.
Ithaca Software, correct.
That was it, Ithaca Software, and which later became Autodesk, and which later became TechSoft.
Yes.
And on the way, Carl Bass stayed at one of the steps called Autodesk.
Yes, exactly.
We were fortunate in a way that we were able to hire somebody that had worked at Prime with Vladimir and that Sam knew, called Leonid Rice. Leonid created the geometry in Pro Engineer. The geometry in Creo today is one of the two best geometric modelers.
This is a code that became known as Granite later?
Modeling inside is what Leonid created. The other best one is CGM.
I think those are the two most renowned modelers.
The more commercially available is ASIS and Parasol.
Granite still is, isn't it?
That Granite is the modeler inside. That they've never really sold it. They put that label on it, but they've never really sold it.
Yeah.
That was an idea of late quarter, I think.
So now I'm reading CAD history by Dave Weisberg, and a lot of this is my research is based on what he said. He mentions Steve Wolf. I don't know if you remember Steve Wolf.
Oh, of course I know Steve Wolf. He was the curmudgeon who called us the dark side later when SolidWorks became part of Dassault Systèmes. And he called it, you went to the dark side. Is that the fellow you mean?
Yes, that's the fellow. He said he was mentioned in Weisberg's book as curmudgeon, like you said, but also he took PTC to task for giving demos that highlighted the benefits or the advantages of PTC without showing any of its deficiencies. And it was a blender, I believe.
I would only say I've never ever heard of a salesperson who would show their disadvantages. They don't do that. I remember a trip I made to St. Petersburg in Russia
Uh-huh.
and met some people that did design work. They said, I can't tell you about that because I'm not a salesman. I said, that's why we want to talk to you, because in the Soviet era, we were used to talking to the people who made it, not salesmen. Engineers are very good sometimes at highlighting the flaws rather than the benefits, and the sales guy is supposed to sell the benefits. Steve Wolf was possibly right. I mean, it was better than anything else out there. He could have acknowledged that instead of saying he didn't say what was wrong with it. Every piece of software has bugs, whatever Microsoft tells you. That's why they shut your computer down twice a week at night.
Every software does have bugs, correct? Weisberg also mentions one thing I wanted to ask you about. He said you left, these aren't his words, but you left PTC in a fit of pique. And that's not his words, that's mine. But he had a management dispute. Those are his words.
He never asked me. The companies got bigger and it was less tutorial and it was ruled by marketing, and it was time to move on somewhere.
So it
And the
wasn't a product
example
company
was
so much.
this.
Would you say
Okay,
not a product company? It was, I think at that point, Steve Wolski
it
was
did
CEO.
well. But there's this embryo system from Microsoft called Windows NT,
Hmm.
which they build as a 32-bit operating system. And they came and gave a presentation about it. When they did, I realized that the world was going to change. But at that time, there was marketing deals with all of these workstation vendors, and the end of the workstation vendors could be foretold simply by hearing about Microsoft and 32 bits. And so I got a copy of that. I sent it to a single guy in Israel, and he created the Pro Engineer running on Windows NT before
Hmm.
Microsoft had formally released it. It was full of bugs, the operating system, but
Yeah.
nevertheless, we made it work. And just one guy.
It's just your skunk works kind of thing. You
Huh?
on your own.
Oh, yeah. And nobody knew about it. And there was this show called AutoFact. And I was asked, could we do a sample of something on Windows NT? I said, no, I got a whole product. So we would show it at AutoFact and people got interested. And then the marketing team come along and say, no, you've got to show it on workstations that we sponsor. That helped me realize that getting into Windows would not be easy, as it later turned out. So that was probably a realization that you don't get to innovate anymore.
Yeah, you don't want to be a part of that.
We would do things because customers asked for them.
Yeah.
Do you think we could do that? Yeah, I think we could do that. I got somebody that we can go
Yeah.
to do that.
They had a product that they were afraid might even cannibalize their main product. It reminds me of what Steve Jobs once said. He said, if you don't cannibalize your own product, somebody else will. To make,
It's the truth. So I did some work with Barry Feidelman, looking at companies for him at this venture. One of them was a group of 5 people who didn't want to talk to me, but Barry said they had to talk to me because they thought I was the opposition. They wanted to do 3D modeling on Windows. I talked to Barry later after I talked to them and said, Well, I kind of like the idea, but there's not enough to make it a minimally viable product. While PTC has at least established a certain, if you want to do this modeling, you've got to do this and this and this. And they're not asking for enough money, they're asking for too long a time, and they don't understand what they got to do. Barry said that's why I won't fund them. This was called Winchester Design. Barry said, well, I'd fund it if you joined it. And I said, well, I wasn't planning on that. And then I go away and think about it. Then I called Barry and said, okay, I'll think about that. I might do it.
This was before the days you could just look them up on the internet. You had to find out who are these guys.
Yes, I had to go and
Is that where you met?
they had a prototype.
Okay.
They had a prototype, had holes in it, to put it mildly. One of the things that had to work right in 3D modeling was be able to do rounds. And it didn't do it very well. The original modeling in it was called ASIS.
Yeah.
But there were other component things. This was where it started getting interesting. We didn't make everything at SolidWorks.
Right.
It became SolidWorks, as you realize. We didn't make everything. Things that we could buy, we bought. And then again, people said we were stupid because you'd never make them all work together. Well, I made them all work together. There was Bruce Morgan. You remember Bruce Morgan?
Yes.
He was in charge of spatial. And Bruce came and he said, I want my money for ASIS. I said, we haven't paid anybody else till we ship the product. And we're not paying you till we ship the product. By the way, ASIS doesn't work for us. He says, what do you mean it doesn't work? I said, you can't do half the things we need to do. And we give you bug reports and you ignore us. It doesn't work. He says, but you still got to pay me. I said, we're not going to pay you. I had already got a DLL for the geometry, but could replace one with another. The other was Parasolid. I showed Bruce, let me show you what you can't do. So I showed him doing rounds, but it still weren't perfect, but were quite good in Parasolid and some other geometry that he couldn't do or didn't work for him. Sometimes it worked. Bruce says, well, which version of ASIS is that? I said, I never said it was a version of ASIS. He said, I still want my money. I said, you ask for it one more time, I'll give you your software back. And I won't let anybody go as a consequence.
You never shipped
his money.
You never shipped SolidWorks with ASIS in it, though, correct?
No, never shipped. So then I gave him his software back and said, Bruce, have a good day. And then we worked out a deal with Siemens. Well, it was Unigraphics at the time, with John Stevenson. And that part is history.
You were a really big fish for Herstick and group to land. You were the head of programming development at PTC.
Yeah.
And here was SolidWorks, just a couple of ragtag developers, if I can call them that. People with a dream, not much, no means.
Actually, it turned out that Tommy Lee did the modeling part, and he was very good. Dave Corcoran did the assembly stuff. I got Linda Loke to be in charge of the drafting and the system stuff. And they hire good people. And eventually, which isn't in his book, I don't think, we figured we couldn't find enough people in Boston area. So we started this office in Cambridge, England. A lot of people who had worked on various CAD things in the past and wanted to work on real products. And some of those people, well, they were really very good.
Isn't Cambridge the place where D-Cubed?
Yes, D-Cubed was in Cambridge.
Uh-huh.
And so was Parasolid development. Yeah. That was convenient. That really helped with Parasolid because we just go there and you got all these bugs to fix. Why don't you fix them?
Was that a surprise to you that you were able to license something?
Graphics, and especially Siemens, have this component business. I found them to be very cooperative and they live up to their contracts. My experience with them was always very good.
Okay.
I got criticized. I had to keep explaining to the board, how do we know that Unigraphics and then Siemens will support it? And I said, because they have in the past, and I have no reason to believe that they won't in the future. And then I had to listen to Bernard saying that.
Oh,
You
Bernard
know that,
Charles at Dassault Systems.
how many years ago? Nearly 30 years ago, Bernard was telling me that.
Yeah.
And they've still behaved properly. You can't be in the component business. And I ran that for DS, Spatial. And you had to treat customers as customers.
Yeah.
And you'd never told the people in Paris what they were doing if they told you. I mean, you kept it completely confidential.
Mike, didn't your title change after SolidWorks was acquired by Dassault Systems? You actually worked for Dassault Systems then, officially.
Yes, yes. We had a handshake agreement on that, not a contract. I stayed for 8 years.
Okay.
And that was, and then 5 of them were making spatial work.
Okay.
But I must say that it did not go the way of acquisitions in some other companies, that SolidWorks prospered with Dassault as the owner, as you can tell.
How was your relationship with Bernard, if I may ask?
Bernard lived up to what he said he would do. Bernard's very smart. And if he's listening, he'd probably agree with it. He asked me to run spatial, and I asked him for time to think about it. He said, fine. And I said, okay, I'll do it the next morning. And I got all the support you ever wanted.
I do know him as a very smart man. He's a mechanical engineer by training.
Absolutely.
It's always great when engineers had their own companies. It's that part is good. You were in a position where you went into Spatial, which sold ASUS, so you could actually correct the mistakes they made in the past. Their modeling wasn't
Oh,
as good as Nanosolids, right?
I mean, well, I knew about some of the mistakes, obviously, from the experience at SolidWorks and what one heard. Okay. And what I discovered, there was an interregnum period. There was 3 months between announcing the purchase and actually closing the deal. So in that 3 months, I learned that it was even worse than I thought it was. The place needed reorganizing. There was no quality assurance. So I took the SolidWorks tests, and 70% of them ran with an ASIS underneath. So I had battery of computers, and I would run these tests and with SolidWorks on ASIS to make sure that ASIS behaved itself and continued working. Because there were no tests. These tests existed. All I had to do was, somebody had put SolidWorks on ASIS at SolidWorks. It wasn't a product, but a lot of the stuff worked. Okay. And so I ran these tests on a big room full of computers, and we would run tests continually. You couldn't break what worked. I didn't put effort into making the other 30% work.
So you left there after 8 years, and then
yeah, well, that was nearly 10 years with SolidWorks.
Did Linda Loke manage that after you left?
Linda Loke came on board with the acquisition, but I put her in charge of marketing because I wanted people who understood the customer's problem and that we were selling to development organizations. I had one of the founders of DS as in charge of development. His name was Didier Boursier, who had recently been in charge of geometry at CGM. He came out for 2 years to help implement some engineering judgment because there wasn't much.
I see. Okay.
And then Linda took over development after the 2 years that Didier was there.
Got it. So you left and then sailed around Nantucket Bay for a little while.
Then somehow I got together with David Taylor and Blake and Danny Dean, and that was SpaceClaim. I did that for a while, and then I didn't do that for a while. Eventually, then a friend of mine had a VC who had a failing company, and the VC said, "Look, we're funded if you run this and make something of it." So what we made of it was a cloud storage product that worked for CAD assemblies. With the cloud, how do you get an assembly with its relationships into the cloud? You can't exactly zip it up and take it there if you have library components, etc. So we came up with this simple idea. Why don't I treat the cloud as a remote disk from your computer? But it's not in your office, it's on the cloud.
This was before Onshape.
Oh, yeah, a bit before Onshape. But
would you say that's the original Onshape?
No, I didn't do anything with the inside of the devices. I only took their files and put them there. And the version, so you got all the versions of everything. You think you got everything on your desktop. Now we have separate projects. We have so much data from some companies that the metadata takes up too much space on your computer. So we made that virtual as well. So you think you've got this vast file system, but really isn't there at all.
If you don't mind, Mike, can I spend a little bit more time on SpaceClaim? Because that's like your trilogy, as it were. Because you started that along with Blake and the others, and then it got sold to Ansys.
Well, that's interesting because it is direct modeling.
Direct modeling.
And now the computers were good enough to do that. It's not easy. And what happened was that very early on in large companies, they have people who design and they use things like CATIA. And the people do analysis use ANSYS. And then, if you want to change your model, you can't do it because the designers won't let you. So what we originally thought was that ANSYS would be a beautiful partner for this. At a very early Needham conference, we showed Jim Cashman of ANSYS this thing, which he got interested in. And 5 years later, they bought it because it allowed them to go into analysis without the regimentation of large companies to be able to let the analyst change the model, and then they could, when they finally made the structure right, give it back to the person who would then put it back into the CATIA model.
All these FEA programs had a very limited modeling capability in
right.
the processor.
And so this was a way that they could change the models.
Yeah.
It was about change, not really create, but change.
Right.
They actually did some dynamic stuff with changing the model, and the simulation was almost in real time updated. It was very impressive.
Let me ask you something about, you said direct modeling, SpaceClaim was their whole strength. I always thought that it must have been somewhat of a change of religion for you because you did all the things that were not direct modeling,
right?
History-based. So here you are now saying, was that like, I'll throw this all out the window?
Oh, not at all. Because look, the direct modeling is more about change rather than create. And in this case, with ANSYS, it was more change by the people who didn't create.
Ah, I see.
It's kind of like, if you like fish, does that mean you won't like steak? It's different. And so that's how we did this document management stuff, which is, it's all related. You evolve things because we keep all these documents, especially for some builders, which are PDFs mostly. We can index them. All of those documents, the RFIs associated, be specs and the rest of it, and find any word or phrase in those documents, which is a natural evolution from saving the documents. Now we save the indexing of documents. That's a good way to describe it. And
Okay.
yes, we can read all the words inside the PDF drawings. You take steps and evolve, and the technology changes. What we can do now, we couldn't do a few years ago.
You realize you did all that without ever mentioning the name of the company. It's Canesto.
Correct. You're right. But that was an evolution. The idea of virtualizing everything sounded crazy, but the computers now, we got enough storage and enough bandwidth to be able to do that. So
Right.
if you click on a folder, it takes a fraction of a second for it to appear, and it will stay during your session.
The cloud offers us unlimited computing, unlimited space. When did you convert to believing that was a good thing? Because that became an evolution for all of us, didn't it?
That goes back to, I remember a discussion at PTC when we went to double byte, we did double byte characters.
Yeah.
There was an argument to be made that if it will double the amount of storage for characters. So we should only do it for people who have a language other than, that needed double byte characters. Chinese or Japanese. No. However, I looked at it saying that will make unreliable software because there'll be too many if statements, and then you'll get it wrong. So we should make them all double byte. And if there isn't enough memory this year, there'll be enough memory next year. Moore's law has almost been followed for decades.
Right. Yeah.
One of the things that we did in very early on was that same discussion about storing the geometry that you last had. That took space, but the disks got bigger. In SolidWorks, it's well known that the pretty picture of the assembly is stored in the assembly. When you bring it up, you immediately have a picture of your assembly and can manipulate the picture, while the rest of the works comes in another thread.
Oh, I see.
And that took more space on a disk. You couldn't have done that in Pro Engineer back then.
Right.
They could do it now if they chose to.
Yeah.
They may have. You evolve. You are dependent on the underlying platform that you're using.
Right. Would you say software is always ahead of the hardware in terms of demands?
It's not just hardware. One of the things we use is a structure S3, which is storage as a service, which spans much more than the address space on a computer. That's how you can store huge amounts of data in what looks like a file system, so to speak, that it isn't.
Okay.
You see, so things evolve and then you need to use them. You can't just fix a few bugs every release.
Right.
You need to advance the product. I'm amazed that none of these CAD companies have managed to figure out how to have a desktop product and a cloud product interoperate and be the same. Why can't
Let me ask you
have...
about that. Doesn't Autodesk says Fusion is like that?
No, it's on your desktop and you store the files in the cloud. They haven't made a Fusion on the web.
Right. Yeah, I've called that the Achilles heel of Onshape.
But they could have stored it in JSON files.
Yeah.
JSON is unbelievably fast to read. We're doing that for our building project, where you take IFC, 1,000,000 lines, and in 6 seconds, you can turn it all into JSON and then read that JSON very fast, like in a second.
Have you mentioned this to John Herstick?
He would tell me all the reasons why he can't do it. But think about it. Why do I care that something's on the cloud or on my desktop? I choose which is the best environment for what I'm doing. How can I use Onshape, to use your example, when my internet goes down? I have Comcast, Xfinity.
Mike, forgive me for comparing myself to greatness here, but we have that in common. John Hirschtig doesn't listen to me either.
If he asked me, I'd tell him. But
Yeah, I told him
why
years
doesn't
ago.
PTC put Creo on the cloud? They could.
Like,
Why? I let the user choose.
yes, definitely.
Look, playing with software, anybody can do. I'm not a computer scientist, but I can find bugs in my developer's software.
You're too
And
humble. I would say you're one of the better computer scientists, no matter what your title says.
I'm an electrical engineer, if anything.
Okay.
And that you learn a bit of mathematics to do electrical engineering. You can't help it. There's all these lovely equations like Maxwell and that sort of stuff. It should be, you can have Outlook, the latest version of Outlook, on the cloud, on your desktop. Who the hell cares? If I don't have a cloud connection, I can still read my email.
I know. How about that? How about
Yeah.
that?
Oh, why I don't have a cloud interface,
Yeah.
which is optimized for the cloud and one for the desktop, but the
It,
files are the same.
maybe we ought to team up on John because years or 10 years I've said this is your Achilles heel. You can't work when I'm offline. This is not good. You need to do something about that. And they've resisted.
Because maybe they don't know how, or it's just supposed to be a tinker toy.
It's got to be,
I don't understand pride. Customers are what counts.
yeah,
You listen to customers. The customer says to us, you've got this lovely project of document management, but
yeah,
we need to account to the FDA for these medical devices. So
yeah,
we need to classify them.
yeah,
So we added in the database classification so all the documents can be classified. And you can choose whatever classifications you like. We found that people use it for other purposes in workflow to say what the state of this job is. Classify it. Then you can get a list of all the things that are active in that classification.
right.
Maybe you try and listen to customers because in the end, customers are what count, not
Yeah,
what I want.
right.
Developers say such things as, I never use it that way. No, you wouldn't. You're never going to build an aeroplane.
Never made anything in your life.
You see that in software, but the people who built the software are never going to use it. It was
Uh,
built for a developer, not for a user.
so true. I was so amazed by a CAD company, which I won't mention their name. Starts with an A though. When I worked for them as a consultant, and I was amazed to find out after I worked there for a full 6 months, not once did I see the program itself on anyone's screen. They were using email, they're using PowerPoint. I was in a marketing group, but you would think somebody there would actually use the product somehow.
Yeah, no, that's the whole point. One
Yeah.
of the things I can tell you about PTC, going back to that, we mostly hired mechanical engineers who
Yes.
I would give them C books and say, learn it tonight, especially if they were the Russians that arrived and wanted jobs.
Uh-huh.
Okay, you don't know C. That's fine. Here's a book. Simple
Because
enough.
much easier than the converse, which is trying to teach a programmer engineering.
I told the American Society of Mechanical Engineers just that. They gave me an award, and I said, I don't know why, but you professors want to teach mechanical engineers programming. They're smart enough to figure out how software works. And but when we did SolidWorks, I had another different books. They're called C plus, and then because nobody knew C plus, so I give them those books and say, learn it,
Yeah.
okay? And there were a lot of people with an mechanical engineering background who were doing the programming, so they knew what dimensions, linear dimensions were, and radial dimensions, and feature control symbols, and all those lovely things.
Uh,
I am a great believer in people, unless you're doing pure math stuff, but then you
yeah.
should be a mathematician.
Oh, I got to call you on that because you learned electrical engineering, right? So you had to learn on the job yourself how to be all these things like feature control blocks and everything, the parts
Well,
list.
you forget that I went to a college where in the first year you had to do all forms of engineering.
Ah, I
So
did
I
not
had to
know
do
that.
something I really hated, which was engineering drawing, where
Ah,
you had to use the right pencil 2H or HB, or to have the right thickness on the lines with a drawing machine and squares. It was horrible. You couldn't smudge it to make it look right. And
had to make all your letters so perfect. It's like,
oh yeah,
oh,
absolutely. I hated it. Computers were a much better way of doing drafting.
do you
We had to
remember
learn.
remember the electric erasers, the little things that had the eraser things that you'd have
Oh yeah.
to remove a line. Those were the lucky guys that had the mechanical erasers. I only had a manual eraser.
Oh, we had to do things like strength of materials, something about civil engineering and mechanical engineering. So that was the first year.
You really had a rounded engineering education.
Yeah, so I didn't have to learn what feature control symbols were. We had to draw the bloody things.
Did you ever have to make splines? You know,
Oh,
mechanical.
yeah, those snake-looking things. Yeah,
Yes, yes.
yeah, there you go.
Nobody in our present
French
generation knows
curves.
what that is. The curves with the little pins they used to stick on in places, the control points.
So that was the second year, all different forms of electrical engineering and electronics, synchronizing machines. I remember somebody did it in the wrong direction on a three-phase motor or generator. That went bang.
When you were studying electrical engineering, you were on the cusp of vacuum tubes to semiconductors.
I didn't learn anything about vacuum tubes. That was pretty easy too, but with semiconductors, the professors have written a book about semiconductor devices. I got into trouble in high school because I chose to I didn't want to go to Oxford or Cambridge and study classics or pure science. I wanted to do engineering, so I went to Southampton.
To Southampton and King's College.
And then King's College.
King's College was your master's?
Sorry?
You got your master's in engineering?
Yes.
You're back at Southampton. You'd still have some affiliation with Southampton?
I advise the students at Future Worlds, encouraging entrepreneurs. This is the England of today.
Okay.
And it's completely, there's an entrepreneurial spirit. Now, I would happen to think, which Martin Day would not, that it was coincident with Brexit.
Oh, we've had this conversation,
With
arguably,
Martin Day. Martin Day knows how to run other countries rather well.
Doesn't he? Yeah. Yes, that brings me back. That was the last place we met.
Don't let me, I'm not knocking Martin Day. On the contrary, he has found a formula for conferences in the mechanical space and in the AEC space. No one else has succeeded. They've all gone by the wayside. He has succeeded in getting a huge number of people from North America to go to his conferences.
That brings me back to the AutoFact, the show you mentioned, and Endes. Remember Endes?
Yeah, it's all gone.
They're all gone. Now people, they have user group meetings.
COFES is gone.
Right. And even user meeting works is no longer, works PTC shows is no longer a thing. That they stopped that. So Martin is kind of doing something great.
He's to be applauded, okay? Yeah. He's found a formula that works and people interchange views. He should allow more time for that because you have chats with people that are in related industries, even competitors. You have competitors that are friends in every other companies, all the time.
Yes,
but they're friends.
Yes, it's a small world we're in, I think. We have.
Yeah, I mean, you're not out to annihilate the competitor. They got to exist because then you do better too.
Absolutely. Competition brings out the best in us.
That's a brief history of my version of the CAD. But we did mention one thing.
What's that?
I mentioned PDMS. That research company was privatized. I was on the board of it. It became known as Aviva, which continued to have success with PDMS, which is still around. When it was privatized, they had more products than employees.
Huh.
And part of sorting that out was to have fewer products than employees. And, and one of the things they focused on was PDMS. And then they made a good business out of it.
They got bought by Hexagon.
That's right.
What happened? I don't hear much about them at all.
It's part of Hexagon now. Probably a natural home for it.
Yeah, a lot of things ended up there. And I think Missy Nastran was
Yeah.
acquired by
And
Hexagon.
so, yeah, exactly. But
Yeah,
I think that is something that goes back to the late 70s, PDMS. That's how long this stuff has been around, 3D modeling.
you had mentioned them before in our conversation about how they were originals, like the original solid modeler.
In
Their
essence,
modeling
yeah, look,
was
it was really lines that were turned into tubes, but
mm,
on the display or effectively. There's lots of graphics tricks you can play, and it's all about evolving. I think what you saw was PTC did not evolve into SolidWorks. What was the difference? It was a more friendly user interface. It was sold through resellers. It at a lower price. It was on Windows. CAD has grown in revenue from the early beginnings on the IBM PC,
mm,
which only shows that when Sam said we won't have to do drafting, it didn't quite turn out that way. So we quickly made two products when somebody would say that they would buy Pro Engineer if we had drawings.
50.
And it will no more go away in building because we have BIM 2.0, according to Martin Day, when we don't even have BIM 1.0 because Revit is really not a BIM model. But even if we did have complete models of buildings,
Yeah,
drawings won't go away for a long time, if ever. They haven't gone away in mechanical.
no, they have not.
And Autodesk continues to sell more AutoCAD and more AutoCAD,
Yes. Yeah,
and not so much Fusion and not so much Inventor.
not so much Fusion. I never hear numbers about Fusion.
I'm sure James Leishow could help with the math.
Yeah.
If they get this from Revit, this from AutoCAD, that doesn't leave much for anything else.
Mike, we've gone way over our time, and I really appreciate that. You've got better things to do than talk to a journalist, I'm sure. That concludes this episode of the History of CAD podcast. Please join me on our next episode, and we will add to the rich history of design and engineering software. If you'd like to be a guest on this show or know someone who has stories to share, please let me know at the email address shown.